All right, so welcome back. We are going to talk about writing and graphing inequalities. So let's talk about what an inequality is and what we would use it for. So right here, we've got a situation. No more than 72 students can ride the bus. Well, in this situation, we could have 72 students riding the bus, right? No more than. That's the max we can have. But we could also have fewer than. So we need, instead of writing an equation like x equals 72, because it's not always going to be 72 kids on the bus, we can write something that says like x has to be less than or equal to, which this is what we call an inequality. So when we're talking about that, right, in that last situation, we were talking about how we could have more, or we couldn't have more than that, but we could have less than. Well, let's just look at this here. What is a number that's greater than 1? Is there only a single answer to that? No, there's not. Right? We could have 5. 5 is greater than 1. 2 is greater than 1. 4 is greater than 1. 3 is greater than 1. And we can also have the points that are in between there. Now, the only number we really can't have, right, is 1. 1 is not greater than itself. So we have a special way of denoting the number that we can be larger than, right? Because we can get really, really, really close to that number, but we're never going to actually touch that number. So let's talk about this. We've got 4 different symbols that we use for when we're talking about inequalities. Less than is going to be the first one we talk about. That's this symbol right here. Typically when we're writing it, it's going to be pointing to the left. So it's the smaller numbers. So in this case, x is less than 1, right? So here's some other phrases you might hear: below, under, fewer than, and that's just a few. That's not all of the ones. So when we're going to show this on a graph, on a number line, we would use an open circle, and we're going to shade to the left, because that's all the numbers that are smaller than 1. Okay, the next one we're talking about is greater than. Okay, this one's the one pointing to the right. Okay, some of the words we use are above, over, more than, exceeds. Okay, these are some things there. When we go to graph this again, we're going to use an open circle at the number that we're going to be at, because we're not including it, but we're going to get really, really close to that number. Okay, and then, but since it's greater than, we want all the numbers to the right. So we would shade our graph to the right. Okay, the next one we'll talk about is less than or equal to. This is something where we are including the number. Okay, so it's equal to. So that number can be part of our solution set. So some of these words are maximum, at most, no more than, not above, up to. Okay, again, these are not an inclusive list. This is just a general list. So when I go to graph this on the number line, I would put a closed dot at 1. And since it's less than, I'm going to shade to the left, because I want all the numbers that are smaller than. Okay, last one that, as far as symbols go, are our greater than or equal to. So just like greater than, we want the numbers that are larger, but since it's equal to, we're also including the number. So these are some phrases you'll hear used with greater than or equal to. So minimum, at least, no less than, no fewer than, not below, not under. Okay, so these are the numbers, the phrases that mean greater than or equal to. When I'm graphing this, I'm going to put a closed dot at -2 in this case. And then because it's greater than, shading to the right. I want those numbers larger. All right, so let's look really quick just to recap. If I've got less than or equal to or less than or greater than, then I'm going to use an open circle. This means I'm excluding that number. It's not included in my, okay? If I've got greater or less than or equal to or greater than or equal to, I'm going to use a closed circle. This means it's included. So less than, we shade to the left of the dot or the number. Greater than, we shade to the right. Now again, note this only works if our variable is on the left side, okay? Otherwise, we have to really think about what we're looking for, okay? Do I want my x to be larger or smaller than my given solution? And again, remember, open dot means we're excluding the number, closed dot means we're including. So let's graph the inequality. X is greater than 3. So this right here tells me, okay, first thing, am I going to use an open or a closed circle? Well, it's not equal to, so we're using an open circle. So we're going to use an open circle at positive 3. Now, since we want x to be greater than, we're going to shade to the right. Okay, let's look at the next one. Now this is again where I talk ordered matters. So if I've got my variable on the right, I can flip-flop the whole thing. Now, if I'm flip-flopping the variable and the number, I also need to flip the inequality sign. So I want to make sure that the side that's pointing towards the variable is still matching. Okay? So first thing we need to look at, is it equal to? If so, I'm going to use a closed circle. So in this case, we're equal to -4. Okay, but x is also greater than -4. So again, we're shading to the right. Okay, x less than 1. All right, I want you guys to answer this one on your own. All right, now let's move on. If we're given the graph, can we write the inequality? Super easy, right? First thing we need to look at is what sign am I going to use? So what side am I shading on? Am I shading on the left side or the right side? In this case, it's shading on the left. So that tells me I'm either using less than or equal to. Next thing, look at your dot. Is it filled in or is it open? In this case, ours is open. So that tells me right there I'm using less than. So we know x is less than, well, my dot is at 2. So in this case, any number that is less than 2 is part of our solution set. Okay? So again, let's look at, am I shading to the left or to the right? Okay, we know that we're shading to the right, so it's got to be greater than. Now, is it equal to? Yes, we have a closed dot. So x is going to be greater than or equal to, in this case, 0. Because that's where our dot is at. Okay, I'm going to do one more with you, and then I want you to try one on your own. So open or close circle and shading to the right or to the left are the two things we have to look at. So first thing we're looking at, shading to the right. So x, well, since we're shading to the right, is greater than, but we have a closed dot, so it's equal to, and in this case, our dot is on -3. All right, try this one. All right, that's it for this one. And I will see you in the next.